Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video is part 2 on the subject of derivatives. It is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. It is recommended that students view derivatives part 1 before watching this video. This video will cover natural exponents, the constant rule, the sum rule, the product rule, the quotient rule, the chain rule, and higher order derivatives. E is an irrational number approximately equal to 2.7182818 and satisfies the following. The limit of e to the h minus 1 over h as h goes to 0 equals 1. So let's take the derivative of e to the x. d dx of e to the x is equal to the limit of e to the x plus h minus e to the x over h as h goes to 0. E to the x plus h equals e to the x times e to the h. Now e to the x factors out of the numerator. If we take the limit as h goes to 0, then e to the x is a constant and can be pulled out of the limit. Now the limit that is left is the definition from above, which equals 1. Therefore, d dx of e to the x equals e to the x. If f is differentiable at x and c is a constant, then d dx of c times f of x is equal to c times d dx of f of x. For example, d dx of 4x cubed equals 4 times d dx of x cubed, which is 4 times 3x squared, which equals 12x squared. If f and g are differentiable at x, then d dx of f of x plus g of x is equal to d dx of f of x plus d dx of g of x. For example, d dx of x cubed plus x squared is equal to d dx of x cubed plus d dx of x squared, which equals 3x squared plus 2x. If f and g are differentiable at x, then d dx of f of x times g of x equals f prime of x times g of x plus f of x times g prime of x. Let's look at an example. H of x is equal to x times the quantity of x minus 1. We can see that this function can be viewed as the product of two distinct functions, so let f of x equal x and g of x equal x minus 1. That will make f prime of x 1 and g prime of x 1. So now we combine our functions. H prime of x is equal to 1 times x minus 1 plus x times 1, which equals x minus 1 plus x, or 2x minus 1. If f and g are differentiable at x, then d dx of f of x over g of x equals g of x times f prime of x minus f of x times g prime of x, all over g of x squared. For example, let h of x equal x cubed minus x over x. Let's separate our functions so that f of x is equal to x cubed minus x and g of x equals x. Then f prime of x equals 3x squared minus 1 and g prime of x equals 1. So we fill in our quotient rule and get h prime of x is equal to x times 3x squared minus 1 minus x cubed minus x times 1 all over x squared. We simplify to get h prime of x is equal to 3x cubed minus x cubed plus x all over x squared. The x terms cancel each other, then combine the x cubed terms to get 2x cubed over x squared. Here x squared can cancel with x cubed to get our final answer, 2x. The chain rule is used to take derivatives of composite functions. Suppose y equals f of u is differentiable at u equals g of x, and u equals g of x is differentiable at x. Then the composite function f of g of x is differentiable at x, and its derivative can be expressed as d dx of f of g of x is equal to f prime of g of x times g prime of x. Using Leibniz notation, the chain rule may also be expressed as dy dx is equal to dy du times du dx. Now we can use the chain rule to find the derivative of the following composite function. Y is equal to 5x squared plus 11x, all to the 4/3 power. We can see how this is a composite function. First, we remember the equation in Leibniz notation of the chain rule. Dy dx is equal to dy du times du dx. Next, we set u equal to the function that is composed. In this case, u equals 5x squared plus 11x. This makes y is equal to u to the 4/3 power. Then we take the derivative, du dx is equal to 10x plus 11, and dy du is equal to 4/3 u to the 1/3. Next, we multiply as described. Dy du times du dx is equal to 4/3 u to the 1/3 times 10x plus 11. Then replace u so that dy dx is equal to 4/3 times 5x squared plus 11x to the 1/3 power times 10x plus 11. Let's look at a second example. This time, find the derivative of the function f of x is equal to 5 over the square root of x to the 4th plus 1. First, the constant 5 in the numerator may be taken out so that we are only finding the derivative of 1 over the square root of x to the 4th plus 1. Next, we let u equal x to the 4th plus 1, making y equal 1 over the square root of u. Let's then express this in rational exponents to make the power rule more clear, or u to the negative 1/2. Du dx will then be 4x cubed, and dy du will be negative 1 over 2 times u to the negative 3 over 2. We then put this back in root form, negative 1 over 2 times the square root of u cubed. Dy dx will then be the product of dy du and du dx, or 5 times the quantity of negative 1 over 2 square root of u cubed times 4x cubed. When we replace u and simplify, we get the final answer dy dx is equal to negative 10x cubed over the square root of the quantity of x to the 4th plus 1 cubed. Assuming y equals f of x can be differentiable as often as necessary, then the second order derivative can be described as follows. F double prime of x is equal to d dx of f prime of x. We can also go to the third order derivative. F triple prime of x is equal to d dx of f double prime of x. Using Leibniz notation, d dx of dy dx is equal to d2y over dx squared. d dx of d2y over dx squared is equal to d3y over dx cubed. For example, find the higher order derivative of the following function. F of x is equal to 10x to the 4th minus 32x plus e to the x. F prime of x will equal 40x cubed minus 32 plus e to the x. F double prime of x will equal 120x squared plus e to the x. F triple prime of x is equal to 240x plus e to the x. If you have further questions on this or any other math topic or wish in-person tutoring, please consult the academic support coordinator on your respective campus. Thank you and good luck with your studies.